So let's take a look at this not Lagrange polynomial, but the other way we were getting the lowest order polynomial before. So in the notes that I put up and in the first Lagrange video, I had this as A, B, C, D, but now I've changed it to match the matrix down here, A0, A1, A sub 2. So notice that the coefficient matches the power of x, right? A0, x to the 0, there's a 1, I didn't write it, a to the 1, x to the 1, a sub 2, x squared, etc. We've got 4 points. We know this is going to be a third order polynomial. So starting counting at 0, there's 4 pieces. First piece, second piece, third piece, fourth piece. When we wanted to find those coefficients, the A0, A1, A2, A3, we put them in this matrix form, and these are the x values. So the x values are 1, 2, 4, and 7. And the first row is for the first x value of 1. It's 1 to the 0, 1 to the 1, 1 to the 2, and 1 to the 3. The second row is for the x value of 2. 1 to the 0, no, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. The next row is for 4, 4 to the 0, 4 to the 1, 4 squared, 4 cubed, and the last row is for 7. 7 to the 0, 7 to the 1, 7 squared, 7 cubed. Multiply by this matrix, get the y values here. The 0, minus 3, minus 1, 10. So to figure out this polynomial, we just needed the 4 coefficients, A0, A1, A2, A3. So we've set it up in a matrix form. All I did in the video was take the inverse of this matrix, and now we know the pattern to get this matrix. Take the inverse of this matrix, multiply it by the coefficients, and that gave me the coefficients of the polynomial. There's A0, there's A1, there's A2, there's A3. And it matched the result that we got from the Lagrange polynomial as well. So thinking about that, let's go back to our example. And now I'm trying to make the function that goes through all these points in this binary straddle. We've got, what do we say? We have 11 points. So I'm going to get a 10th order polynomial. So it's like this, but I've got A0, A1, A2, A3, A4, all the way up to A sub 10. So I need a 10 by 10 matrix here. That's what this is here. This is this 10 by 10 matrix. So the x values are the 0, 1, 2, 3, 4, 5, all the way up to 10. Those are the x values of my points. And so each one of these x values is getting a row. This is 0 to the 1, no, the power of 0. 0 to the 0, which is 1, and then 0 to the power of 1, 0 squared, 0 is 6, all of that. This is for the 1, 1 to the 0, 1 to the 1, 1 to the 2, etc. So across the top I've got the power, like the 4 to the 0, 4 to the 1, 4 squared, 4 cubed. And over here I've got it as the x value, so that's like I'm pointing at, like you can see where I'm pointing, the A7, that's the x value, the stock value, raised to the power at the top, and then that fills in all of this 10 by 10 matrix here. This 10 by 10 matrix, right, it's in the 5 row, so that's 5 to the power of 4. This 10 by 10 matrix is like this 4 by 4 matrix for our examples. So I need to get the inverse of this matrix, the 10 by 10 matrix, and then multiply it by a big long vector of the y values. So first let's get the inverse, which is, I know in class I always said, oh, it's easy to find. I know I can do it in Excel, I just don't know how. Well, I think I figured out how to do it, and it wasn't as easy as I thought. But let's see what we're going to do. The first thing you got to do is you want Excel to place the whole matrix, so I colored in enough space for it. So this is an 11, by 11 matrix. So I put a space, I just colored it so I could see where it was going. That's an 11 by 11 spot for it to go. So I want, because I want to be able to do this, and I want that to be equals. Now here's the command. It's inverse, but it's for a matrix, so it's minverse. And I want to minverse this whole array. Now, if I hit return, it's only going to fill in that one cell. So before I hit return, oh wait, it didn't catch. I wanted to inverse all of that. Now it caught. So close bracket, but I'm not hitting return yet. I'm going to hold control, I'm going to hold shift, and now I'm going to hit return. And it fills the whole thing in then, because it was all, I pre-highlighted it before I typed the command in. So now this is the inverse of that matrix. Okay, so now we need to know, I need to multiply this matrix by the vector that's the y values. The vector that's the y values is right here. That's the y values of those points. So I need a place to put it. So the place to put it is going to be 1 by 11. So let's put it, okay, make this a little bit smaller. Let's put it right here, because I know that that's the right size. So let's put it there. So now it's, for inverse it was m inverse, minverse. For multiplying it's going to be equals m matrix multiply. And now I want this to be the first array. And then comma the second array, but I forgot to highlight that whole thing. So I want to put this all in here. So I've highlighted it. Now it's going to be equals mult the first array, comma the second array, close brackets. Now I'm not hitting return yet. Control Shift Enter. Now each one of these should be the coefficients then of, this should be the constant coefficient. This, so the polynomial then, the polynomial that goes through all these points should be this number plus this number times x plus this number times x squared plus this number times x cubed plus this number times x to the fourth plus this number times x to the fifth, this number times x to the sixth, this number times x to the seventh, this number times x to the eighth, this number times x to the 9, this number times x to the 10, and that'll be the 10th order polynomial that goes through these points exactly. And we built it with Excel. Now, it's nice to build it with Excel because you can see, because we learned two things in this, how to multiply, or at least I learned two things making this video, how to multiply matrices in Excel. I knew we could do it, but now I hope I remember how to do it. And how to take the inverse of a matrix. I'd done it a long time ago, but I forgot, and now I figured it out again. And we can see this, but I'll bet in MATLAB it would be way easier to do, right? Building this matrix would be easier because there's a nice straight formula, which is probably easier to see here, right? The x value, each row would be just the particular x value to the 0 to the 1, or I wouldn't even write that one to the 0. I just always write that as a 1. But we could build that matrix and then easily take the inverse in MATLAB. And I'll bet MATLAB has a Lagrange polynomial command as well. But anyway, now we know how to do that. Now we know how to do that with Excel. So those points I gave you in asked you to get the Lagrange and then check the answers that I've got up on the My Courses. You could also take a look at I've done the same polynomial but using this technique.